Namaste everyone. Welcome back to the first PU physics class, that is thermodynamics. In thermodynamics we have seen various processes, that is we have seen isothermal process, adiabatic process, isobaric process, isochoric process. So we have reversible and irreversible process. When we say that a process is reversible, a process is said to be reversible process if that process can be made to go back in the reverse direction, so that all the changes occurring in the forward direction are exactly reversed in the reverse direction. This is possible only in case of a slow process. In case of a slow process, all the changes which are occurring in the forward direction can be reversed in the reverse direction. So a slow isothermal compression or a slow isothermal expansion is the best example for reversible process. So a process is said to be reversible which can be made to go back in the reverse direction, so that all the changes occurring in the forward direction are exactly reversed in the reverse direction. So if a process is like this, then we call that process as reversible process. So the example for reversible process is a slow isothermal expansion or a slow isothermal compression. Always remember, slow process is reversible. Next one is irreversible process. When we say that a process is irreversible, a process is said to be irreversible which cannot be made to go back in the reverse direction. That means here what are the changes occurring in the forward direction are not reversed in the reverse direction. This kind of process is called irreversible process. So the best example for irreversible process is a sudden process. It may be sudden compression or it may be sudden expansion. So reversible process and irreversible process, this is the basic difference between them. So this is important, or this may be asked for 1 marks. What is reversible process, and give an example for reversible process. At that time you have to write the statement first and then one example. Similarly, what is irreversible process and give one example for irreversible process. If this is a question, then you have to write this statement and then the example for irreversible process. So with this, our theory part is over. Now let us see some problems on efficiency, work done, etc. Let us see. So this is the first problem. So a Carnot's engine takes 2095 joule of heat per cycle from the source. So we know that in case of a heat engine, heat energy taken from the source is represented by Q1. So Q1 is given, that is Q1 is equal to 2095 joule. So a Carnot's heat engine takes 2095 joule of heat, that is heat energy absorbed. Heat energy absorbed is always represented by Q1. So Q1 is given from the source at 400 Kelvin. That means temperature of the source is 400 Kelvin. The temperature should be in Kelvin. If it is in degree Celsius, then you have to convert from degree Celsius to Kelvin scale. I think you know the formula. How to convert degree Celsius to Kelvin scale? T is equal to Tc plus 273.15. So it is already in Kelvin scale, so no need to convert it. So 400 Kelvin. So T1 is given, T1 is 400 Kelvin. Next, what is given? And rejects 1676 joule of heat to the sink. Heat energy rejected to the sink is 1676 joule. That means Q2 is given. So, Q2 is equal to 1676 joule. Calculate the temperature of the sink. Temperature of the sink or the temperature of the cold reservoir is represented by T2. So, we have to calculate the value of T2. And then what is work done per cycle? W is equal to how much? Third one, efficiency of the engine, that is eta. Eta is equal to, we have to calculate the value of T2, W and efficiency eta. So, let us see it one by one. We know that work done, we can easily calculate work done, because in case of heat engine, work done W is equal to Q1 minus Q2. So, W is equal to, what is the value of Q1? 2095 minus Q2 is 1676. So, W is equal to, so you can use the normal calculator. Always remember, do not use scientific calculator. Okay. So, Q1 is 2095 minus 1676 is equal to, what is the value? 419. So, 419 SI unit of work. Work is a form of energy. So, 419 J, that is joule. So, during one cycle work done, W is equal to 419 joule. Next, the temperature of the sink, that is T2. We know that efficiency eta is equal to 1 minus T2 by T1. Efficiency is not given. So, eta is equal to 1 minus T2 by T1. We have to calculate eta. For that we have another one formula. Eta is equal to 1 minus Q2 by Q1. In terms of heat energy, this is the formula for efficiency. In terms of temperature, we have another formula, that is eta is equal to 1 minus T2 by T1. So, here we know the value of Q1, Q2 is also given. So, we can easily calculate efficiency. So, efficiency eta is equal to 1 minus Q2, 1676, right. So, 1676 divided by Q1 is 2095. So, efficiency eta is equal to 1 minus 1676 divided by 2095. One 1676 divided by 2095 is equal to, this is 0.8. 1 minus 0.8 is 0.2. So, this is the efficiency, or 20%. In terms of percentage, 0.2 is nothing but 20%. Out of 100, efficiency of the engine is only 20%. So, this is the efficiency. Now, we can easily calculate T2, because eta is equal to 1 minus T2 by T1. Eta is 0.2 is equal to 1 minus T2 divided by T1 is 400. So, T2 by 400, bring this T2 by 400 this side. So, T2 by 400 is equal to 1 minus 0.2, right. T2 by 400. So, minus T2 by 400, when it comes here plus T2 by 400. So, 1 is there, 1 plus 0.2, when it comes here plus becomes minus. So, 1 minus 0.2 is 0.8. So, T2 is equal to cross multiplication 0.8 into 400. So, this is the value of temperature of the sink. So, into 400 is equal to 320 Kelvin. So, temperature of the sink is 320 Kelvin, efficiency of the engine is 0.2. In terms of percentage, that is 100 ಅಲ್ಲಿ ಎಷ್ಟು ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಿದ್ರೆ ಇಂಟು 20% ಆಗ್ತದೆ ಅಲ್ವಾ, ಇಂಟು 100 ಮಾಡಬೇಕು ನಾವು ಇದಕ್ಕೆ. ಇಂಟು 100 ಮಾಡುವಾಗ ಎಷ್ಟಾಗ್ತದೆ ಪರ್ಸೆಂಟೇಜ್ 20%. ಸೊ ವರ್ಕ್ ಡನ್ ಈಸ್ 419 ಜೌಲ್. ಸೊ ಎಲ್ಲ ಫಾರ್ಮುಲಾಸ್ ಗೊತ್ತಿರಬೇಕು, ಬೈ ಹಾರ್ಟ್ ಗೊತ್ತಿರಬೇಕು, ಆಗ ಮಾತ್ರ ಪ್ರಾಬ್ಲಮ್ಸನ್ನು ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕಾಗೋದು. ಸೊ 5 ಮಾರ್ಕ್ಸಿಗೆ ಕೇಳ್ತಾರೆ ಎಕ್ಸಾಮಿಗೆ ಇಂಥ ಪ್ರಾಬ್ಲಮ್ಸ್. Q1, Q2 values are given, T1 is given. So, you have to calculate T2 and then work done and then efficiency. So, take down. So, this is the second problem. The second problem is like this: a Carnot's heat engine has efficiency 25% when the sink is at 27 degrees Celsius. Efficiency of the engine is given, that is eta is equal to 25%. In terms of percentage, efficiency of the engine is 25% or eta is equal to 0.25. Both are same. When the sink is at 27 degrees Celsius, that means T2 value is given. Temperature of the sink is always represented by T2. So, T2 is 27 degrees Celsius. It is in degree Celsius. You have to convert it into Kelvin scale. Degree Celsius. So, T2 is equal to, in Kelvin scale, T2 is equal to 27 plus 273. So, T2 is equal to 300 Kelvin. This is temperature of the sink in Kelvin scale. It is desired to increase the efficiency to 40%. Efficiency of the engine is 25%. So, our aim is to increase the efficiency of the engine to 40%. You have to increase the efficiency of the engine to 40%. Then calculate the temperature to which sink alone is to be decreased. The temperature to which sink alone is to be decreased. What we have to do? Initial efficiency is 0.25, T2 value is given, we do not know the value of T1. So, let us calculate temperature of the source, that is T1. So, eta is equal to 1 minus T2 divided by T1. So, efficiency is 0.25 is equal to 1 minus T2 by T1. T2 is 300 divided by T1 value is, T1 is, we have to calculate the value of T1. So, 300 divided by T1. So, minus 300 by T1, when it comes here plus 300 by T1 is equal to 1 minus 0.25. So, 300 divided by T1 is equal to 1 minus 0.25 is 0.75. Therefore, T1 is equal to, cross multiplication, T1 is equal to 300 divided by 0.75. So, what is the value of T1 then? 300 divided by 0.75. So, T1 is 400 Kelvin. Always remember, T1 must be greater than T2. Temperature of the source must be greater than temperature of the sink. So, T1 is 400 Kelvin, T2 is 300 Kelvin. Okay. Now, let us see the second part. Our aim is to increase the efficiency to 40%. Initially, it is 25%. We have to increase it to 40%. Calculate the temperature to which the sink alone is to be decreased. Calculate the temperature to which the sink alone is to be decreased, keeping the other temperature constant. That is, in the second part, efficiency is 40%. It is given in the question. So, eta is equal to 40% means 0.4. We have to calculate T2. In order to increase the efficiency to 40%, T2 must be changed. So, what is the value of T2 when efficiency is 40%? Keeping the other temperature constant, that means T1 value is, T1 is equal to 400 Kelvin. Now, we are calculating the value of T2 when efficiency is 0.4, but the initial temperature of the source is fixed. It is already given in the question, keeping the other temperature constant. That is, while calculating T2, T1 is constant. So, T1 is equal to 400 Kelvin. So, eta is equal to 1 minus T2 by T1. Okay. The temperature to which sink alone is to be decreased, that means how much the temperature of the sink is decreased. So, for that we know the value of T2. When efficiency is 25%, T2 is 300 Kelvin. Now, we are decreasing the value of sink, T2 minus something, right. So, we are decreasing the value of the sink. So, eta is equal to, eta is 0.4 is equal to T2 divided by, 1 minus T2 divided by 400, that is T2 by 400 is equal to 1 minus 0.4, which is equal to 0.6. So, T2 is equal to 400 into 0.6, 240. T2 is 240 Kelvin. So, initial temperature of the sink is 300 Kelvin and its temperature is decreased to 240 Kelvin. So, T2 is 240 Kelvin. So, temperature of to which the sink alone is to be decreased. So, T2 is 240. Next one, the temperature to which source alone is to be raised for the same efficiency. For eta is equal to 0.4, what is the value of source? That you have to calculate, keeping the other temperature constant. That means other temperature is temperature of the sink. T2 is constant now, T2 is 300 Kelvin, This is not the value of T2 for this part. Okay, T2 is constant 300 Kelvin. For eta is equal to 0.4 and T2 is equal to 300 Kelvin, what is the value of T1? So, how to calculate the value of T1? So, I will write here T2 is equal to 240 Kelvin. So, in the third part, efficiency is same 40%, that is 0.4. T2 is 300 Kelvin. What is the value of T1? So, eta is equal to 1 minus T2 by T1. Eta is 0.4 is equal to 1 minus 300 by T1, or 300 by T1 is equal to 1 minus 0.4. 1 minus 0.4 is 0.6. So, T1 is equal to 300 divided by 0.6 is equal to 300 divided by 0.6. This is 500 Kelvin. T1 is 500 Kelvin, T2 is 240 Kelvin when efficiency is 40%. In order to increase the efficiency to 40%, you have to increase the temperature of the source from 400 Kelvin to 500 Kelvin. At the same time, temperature of the sink is to be decreased from 300 Kelvin to 240 Kelvin. So, this is how you can solve the problem. Take down. So, this is the third problem, another problem. The efficiency of the Carnot's engine is 20%. Efficiency of the engine is given. So, we can write eta is equal to 20%. This is in terms of percentage. So, eta is equal to 0.2. When the temperature of the sink is reduced by 100 degrees Celsius, efficiency increases to 40%. That is, efficiency becomes 40% when temperature of the sink is reduced by 100 degrees Celsius. When T2 is reduced by 100 degree. That is, if initial value of the sink is T2, then on increasing its efficiency from 20 to 40%, temperature decreases by 100 degrees Celsius. Initial value is T2, therefore, the final value is T2 minus 100. We are decreasing it by 100 degree. So, T2 minus 100. Decreasing or reducing the temperature by 100 degrees Celsius, that is T2 minus 100. Okay. ಈಗ ಇಲ್ಲಿ ನಿಮಗೆ ಡೌಟ್ ಆಗ್ಬೋದು, ಇದನ್ನು ಕೆಲ್ವಿನಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಲಿಕ್ಕೆ ಉಂಟಾ? ಡಿಫ್ರೆನ್ಸ್ ಸೇಮ್ ಅಲ್ವಾ? ಈಗ ನೋಡಿ, 20 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ we are increasing the temperature from 20 to 30. Difference is to 30 minus 20 is equal to 10 degree Celsius. ಸರಿ ಅಲ್ವಾ? ಇದನ್ನು ಕೆಲ್ವಿನ್ ಸ್ಕೇಲಲ್ಲಿ ಬರೆಯುವ ನಾವು. 20 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಕೆಲ್ವಿನ್ ಸ್ಕೇಲಲ್ಲಿ ಎಷ್ಟಾಯಿತು? 20 plus 273. This is 293. ಇದನ್ನು ಕೆಲ್ವಿನ್ ಕನ್ವರ್ಟ್ ಮಾಡಿ. 30 plus 273, right? So 303 Kelvin. What is the difference? Same, 10 Kelvin. 303 minus 293 is 10 Kelvin. So decreasing the temperature or increasing the temperature by 100 degrees Celsius means we are decreasing it by 10 Kelvin. ಎರಡರದ್ದು ಮೀನಿಂಗ್ ಸೇಮೇ. ಡಿಫರೆನ್ಸ್ 10 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಂತಂದರೆ ಕೆಲ್ವಿನ್ ಸ್ಕೇಲಲ್ಲಿ ಕೂಡ ಡಿಫರೆನ್ಸ್ 10 ಕೆಲ್ವಿನೇ ಬರ್ತದೆ. ಸೊ ನಾವು ಅದನ್ನು ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ಸಲ್ಲಿಂತ ಬರ್ದದಲ್ಲ, ಡಿಫ್ರೆನ್ಸನ್ನು ಬರ್ದದ್ದು. ಸೊ ಇನಿಷಿಯಲ್ ಟೆಂಪರೇಚರ್ T2 ಎಫಿಷಿಯನ್ಸಿ 40% ಆಗಬೇಕಿದ್ರೆ ಟೆಂಪರೇಚರ್ ಏನಾಗ್ತದೆ 100ನಷ್ಟು ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. ಎಷ್ಟು ಅಂತ ಗೊತ್ತಿಲ್ಲ ನಮಗೆ ಇನಿಷಿಯಲ್. ರೆಡ್ಯೂಸಸ್ ಬೈ 100. ಸೊ T2 minus 100. 100 degree Celsius or 100 Kelvin. Same, both are same. Difference is always same. So T2 iddadu T2 minus 100 ಆಗ್ತದೆ ಈಗ. Find the initial temperature of the source and the sink, T1 and T2 values. Efficiency eta is equal to 0.2, it is already given. We know that efficiency eta is equal to 1 minus T2 by T1. Efficiency is given 0.2 is equal to 1 minus T2 by T1. ಇದು ನಾನು ಈ ಡಾಟಾಕ್ಕೆ ಮಾತ್ರ ಬರೀತಾ ಇರೋದು ಫಸ್ಟ್ ಕೇಸಲ್ಲಿ. or T2 by T1 is equal to T2 by T1 is equal to 1 minus 0.2. 1 minus 0.2 is 0.8. So T2 by T1 is 0.8. ಇದು ಹೀಗೆ ಇರಲಿ. For the second part, for this part, we are using the same formula. Eta is equal to 1 minus T2 by T1. Here T2 is decreased by 100. So eta is equal to 1 minus T2 iddalli T2 minus 100 anta haki. Initial value if T2 is 400, then 400 minus 100 is 300. Direct agi baribodu. Namage T2 value gottilla. So value minus 100 divided by T1. So eta is equal to 1 minus idannu nodi 1 minus this equation is T2 by T1 minus 100 by T1, right? T2 by T1 minus 100 by T1. Efficiency eta is equal to multiply ಮಾಡಿ 1 minus T2 by T1 minus into minus plus 100 by T1, right? T2 by T1 efficiency eta is equal to 1 minus T2 by T1 is 0.8. So in the place of T2 by T1 write 0.8 plus 100 by T1. Efficiency is given, that is 40%. So 0.4 is equal to 1 minus 0.8 plus 100 divided by T1. 0.4 is equal to 1 minus 0.8 is 0.2 plus 100 by T1. 100 by T1 idillerli is equal to 0.4 ಈಚೆ ತನ್ನಿ 0.2 minus 0.2, that is 0.4 minus 0.2 is 0.2 is equal to 100 by T1. 100 by T1 is equal to 0.2 or T1 is equal to 100 divided by 0.2. So T1 is equal to 100 by 0.2. 100 divided by 0.2, 500. Temperature of the source is 500 Kelvin. Temperature of the source is 500 Kelvin. Now what is the temperature of the sink? From this equation T2 by T1 is equal to 0.8. T1 is 500, is equal to 0.8. So, T2 is equal to 0.8 into 500. So, T2 is equal to 500 into 0.8 is equal to 400 Kelvin. So, temperature of the source is 500 Kelvin, temperature of the sink is 400 Kelvin. So, this is the answer. Take down.